Welcome to Nikiso's presentation. Today, I would like to share dialysis adequacy with the DBBX series, continuous and real-time dialysis dose measurement. Agenda. First, I will explain some background information to lead the challenge of dialysis facilities. Then, I will propose our solution, which is Dialysis Dose Monitor, DDM. Finally, I will conclude with its customer value proposition. Now, please enjoy the presentation. Challenge of dialysis facilities. Dialysis dose and prognosis. Several studies have proven that a positive long-term prognosis and improved quality of life depend on the actual delivery of dialysis doses. Adequate dialysis dose may improve patient QOL. It is reported that increasing dialysis dose reduces the crude death rate. It is reported that more dialysis dose reduces mortality risk. On the other hand, it is also reported that the inverse correlation between dialysis dose and death risk reduces when dialysis dose is greater than urea reduction rate 65% or SPKT over V 1.3. Large-scale prospective study of dialysis dose, HEMO study, did not observe the improvement of prognosis when dialysis dose was more than SPKT over V 1.2. KDOQI Guideline. Based on these studies, the KDOQI Guideline recommends the minimum dialysis dose should be SPKT over V of 1.2, and the target dialysis dose should be SPKT over V of 1.4. Why minimum dialysis dose and target dialysis dose are different? Insufficient dialysis dose. This table shows the relationship between target dialysis dose and subsequently achieved dialysis dose of HEMO study patients. When the target dialysis dose was 1.2, only 47% of patients reached the minimum dialysis dose of 1.2. When the target dialysis dose was 1.4, 97% of patients reached the minimum dialysis dose of 1.2. What is the possible reason to reduce the actual delivery of dialysis dose? No countercurrent flow of blood and dialysis fluid due to incorrect dialyzer coupler connection. Access recirculation. Reducing effective treatment time due to the frequent alarms or self-tests of the dialysis machine. Reducing effective blood flow, etc. The dialysis dose with blood sampling cannot detect insufficient dialysis doses during the treatment for the correction. And it is not possible to assess every treatment. The real-time dialysis dose monitoring methods can detect insufficient dialysis doses during the treatment for the correction. Sodium dialysis method. One of the real-time monitoring methods is called the sodium dialysis method. It assesses the clearance of the treatment by measuring sodium dialysis across the dialyzer membrane. The sodium dialysis method applies sodium bolus to the dialyzer from the dialysis fluid side. It obtains the sodium dialysis by measuring dialysis fluid conductivity difference between pre-dialyzer and post-dialyzer. The good points are that the sodium dialysis method does not require blood sampling or consumables. Therefore, it can be used at every treatment. And it can detect insufficient dialysis dose during the treatment for correction. This is a challenge of the sodium dialysis method. Due to that, it measures sodium dialysis with sodium bolus, it cannot be continuous, it measures only every 20 to 30 minutes. The sodium dialysis methods cannot monitor insufficient dialysis doses in measurement intervals. This is another challenge of the sodium dialysis method. The sodium dialysis method measures sodium dialysis clearance, K. But it requires accurate treatment time, T, and total distribution volume, V, to calculate KT over V. Especially, the commonly used equation tends to overestimate total distribution volume, V. And it is a potential error risk of KT over V. It is reported that commonly used equations to predict the total body water markedly overestimate the urea distribution volume of dialysis patients. Various studies concluded that sodium dialysis methods commonly underestimate Kt/V compared with blood sampling Kt/V with Daguerre's formula. Challenge of dialysis facilities. Long-term prognosis and improved QOL depend on dialysis dose. Various reasons may reduce delivered dialysis doses. Therefore, the challenge of dialysis facilities is securing appropriate dialysis doses by assessing insufficient treatment. Real-time dialysis dose monitor is the key to assess insufficient treatment on time, which is easy enough to monitor every treatment. Continuous without measurement interval. Accurate without total distribution volume. Proposed solution. Dialysis dose monitor. Proposed solution. The proposed solution from Nikiso is dialysis dose monitor. DBBX series provides real-time dialysis dose monitoring to assess insufficient dialysis dose, which is easy, non-invasive, no consumable required, automatic, continuous without measurement interval, and accurate without total distribution volume. Dialysis dose monitor. It is known that the UV absorbance of spent dialysis fluid at a specific wavelength directly correlates with patient blood urea nitrogen (BUN) concentration. DDM measures UV absorbance change of spent dialysis fluid. DDM obtains Kt/V and urea reduction rate from UV absorbance change of spent dialysis fluid. And DDM displays Kt/V and urea reduction rate in graphic form with a projection line. UV absorbance method. DDM measures UV absorbance of spent dialysis fluid to obtain Kt/V. Therefore, DDM is a real-time dialysis dose monitor which is easy, non-invasive, no consumable required, and automatic, and continuous, no measurements interval. DDM uses Daguerre's formula. Therefore, it does not use total distribution volume, V. Therefore, DDM is a real-time dialysis dose monitor, which is accurate without total distribution volume, which tends to be overestimated, potential error risk of Kt/V. Nikiso develops and manufactures Deep UV LED in special wavelength with Nobel Prize winner. Nikiso's Deep UV LEDs boast one of the highest level emission intensity and lifespan in the world. DDM uses Nikiso's original Deep UV LED. Proposed solution. DBBX series provides real-time dialysis dose monitoring to assess insufficient dialysis dose, which is easy, non-invasive, no consumable required, automatic, continuous without measurement interval, and accurate without total distribution volume. Customer value proposition. Customer value proposition. DBBX series with DDM provides dialysis facilities. Easy dialysis dose monitor for screening all treatments. Continuous and real-time monitoring to secure appropriate dialysis dose. Accurate dialysis dose measurement without total distribution volume. Please contact the international partner or sales representative when there is any inquiry for Nikiso products. Thank you very much for your time and attention.